Hi there, we're looking at rational exponents today. We're going to look at square roots, cube roots, things to the 1/2 power, 1/5 power, and so forth. When we are looking at even roots, we say that we are looking for the positive square root, or the positive 4th root or 6th root, or something of that sort. When we are looking at cubed roots and 5th roots, now our answers can be negative, because basically what we're doing is we're looking for something like, if I look at, say, the square root of 16, what times what gives me 16? Well, that answer is 4, but if you really think about it, -4 times -4 is 16, but we want to define our square roots in such a way that they'll be functions. So we say we restrict this to only be the positive square roots. So make sure that you are writing down the positive answer when you have an even root. Now, cubed root can only have one answer. If I looked at, say, cube root of -8, that must be -2, oops, put a cube here, -2 times -2 times -2, cubed root, it must be -2, and it cannot be +2. The same way, the cube root of 8 must be 2, because the negative version wouldn't work for that. So the cube roots and the 5th roots and 7th, any of your odd roots can have negative answers, but those even roots you're going to have to be careful with. And that's what all that mess over there on the other side, the definitions, where we're talking about the different roots. So let's look at some problems and see what we can do here. Oh, I've already looked at this one. This would be, I'm looking for things to come out in triplets, because that's what that 3 there represents. So is there a triplet that makes a -8? And there is. It is -2. So this answer equals -2. For this one here, there's not anything that will make a -4 as a pair, because -2 times -2 is +4. So this one, we say it doesn't have a real solution. If you've done imaginary numbers before, then you would know that the answer to this would be 2i, but we're not quite there yet. We're going to cover that in a different section. Just kind of disregard that for now and just say that these imaginary things for us are not real. Doesn't have a real answer, and that's the way we'll describe it. Now this one, notice that the negative is on the outside. So the negative, and is there a pair that makes a +25? Well, there is. There's my pair right there. I take that out. When he comes out, he's just a plain old 5, and that negative is still on the outside. This is a 5th root, so I need to find something that 5 of them make 32. It's going to be pretty tiny. And negatives work for my odd roots. If I were to try this, I'm going to try -2. And let's watch this one work. 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 is 32. There's 5 of these -2s, and 5 negatives do make a negative. So there's my 5 that I can bring out. This is a 4th root, so it's an even root with a negative on the inside. Once again, I'm going to say that this is not real. And if you know about your imaginary numbers, then you might be able to have an answer for that, but we're going to disregard that for right now. So let's look at this one down here. When they start getting letters in there, they start getting a little crazy, but just remember, you're looking at things in terms of pairs. There's an understood 2 here. If it's not listed, it's a square root. That's the thing you're going to deal with the most. Yes, everything works with these cube roots and 4th roots, but we're going to be dealing with square roots the most. Remember that you want to take things out in pairs. So I'm just going to write these out really the long way. And I take things out in pairs. So if I take this guy out, he's now a 5. I can take out this A pair and this pair of A's. When I take them both out, I have A squared left because that A times this A gives me A squared. 1 pair, 2 pair, 3 pair. When I take each one out, that's going to be 3B's or B cubed. This one, I'm going to write all out. What a pain. 1, 2, 3, 4, 5, 6. 12 Y's. Are you kidding me? 5, 6. 1, 2, 3, 4, 5, 6. Okay. So I'm going to take out triplets. There's a triplet. There's a triplet. I take out this one and this one. That's an X. That's an X. So I get X squared left. Triplets. There's 1, 2, 3, 4 triplets. X to the 4th. Now, you don't want to write all those things out because you can see that that's kind of messy. What I could have done was I could have said, oh, it might just be easier to divide. And that's one quick way, if you remember that, to say how many triplets do I have here? Well, if X to the 6, that means 6 divided by 3, I have 2 triplets. How many triplets do I have for the Y's? 12 divided by 3 is 4. That's a quick way if you remember it that way, if you don't want to write them out. And as you can see, I do not want to write out S to the 20th, so I'm going to do that. But for my 81, let's watch that 81. That is 3 times 3 is 9, times 3 again is 27, times 3 is 81. This R to the 8th and S to the 20th, I'm going to do that quick way. So I'm looking for things in groups of 4. So that, let me put my 3 back on there. That comes out as a 3 because there's one group of 4. How many groups of 4 do I have for R to the 8th? 8 divided by 4 is 2. How many groups of 4 do I have for S to the 20th? That's S to the 5th. All right, let's get some more problems. Another handy way to write our rational exponents, if we have, square root of 16, there's an understood 2 there. And we could write that as 16 to the 1/2, where 16 is to the 1st power, and this is the number that goes in the denominator, and I could say that that is 4. Sometimes it's easier and sometimes it's not. Sometimes it's easier to put it back in that radical form. This is called the radical form, and of course this is called the exponent form right here. So if I had, say, let's say the cubed root of, how about 27? I could have written that as 27 to the 1/3 power. And I'm telling you, that'll come in handy. Doesn't look like it will, but for now, we'll find the relationship between these exponents and the radicals because it's easier for me to look at this as the cube root of 8 and then tell you that the answer is 2 because 2 times 2 times 2 is 8. It's easier for me to look at this as the square root of 36 and say that answer is 6. Notice here that the negative is on the outside and the 1/2 is solely on the 25. So this is like negative the square root of 25. So this answer is -5. In contrast, this has the negative on the inside. Notice that the negative is on the inside of that 1/2, and this answer is not real. So for this one, you're doing the square root of 4/9, and that answer would be 2/3 because 2/3 times 2/3 is 4/9. You could have also written that as the square root of 4 over the square root of 9 if that makes you happier. All right, and we're reviewing our exponents rather quickly. And if you've forgotten some of this exponent work, be sure to email me and I can help you walk through any trouble that you might be having. You can also go to the, if you'll look in your XYZ course, you'll notice that I included in that this review of exponents and polynomials. You can go to the Chapter 5 ebook and you can look at, say, their 5.1. You can look at their review of that, let's see what they've got in here so that you can look at this and notice that it reviews all of your different properties. I'm going to list the properties and work through the properties, but this was in your 055 course, just giving you a reference so that you can go and get that material if you need to. So I'll get this stuff out of here. And I'm going to go through some of this rather quickly, and it may be too quick if you have not covered exponents in a while, or you just need some extra review. Be sure and email me, and I'll be happy to go through any of that with you. All right, so for this one, the 3 is your root, so I'm looking at the third root of 8, and then all of this to the second power. That's what this 8 to the 2/3 means. So what I would do is take the third root of 8, which is 2, square it, and this answer would be 4. On this one, it's going to be the square root, so the 2 goes here, and it's 25, and the whole thing is then cubed because of that 3 there. So I would have 5 cubed, and 5 cubed is then 5 times 5 is 25 times 5 again is 1, 2, 5. This negative exponent might be something that you've forgotten, but what that means is 1 over. That's what a negative exponent means. I can go through that with you in more detail if you need me to. But this 2 in the denominator means square root 9, all to the third power. So this answer will be 1 over 3 cubed. So it would be 1 over 27. For this guy, the negative exponent means that I flip it. So I'm just going to do that first and write 8 over 27. If you've forgotten that, it's understandable. A lot of people do. So I flip that. That's what the negative exponent means. Then I'm going to take the cubed root of all of this. That's what this 3 means. 27, all raised to the 4th. So that would be 2 over 3 quantity to the 4th. 2 to the 4th is 16, and 3 to the 4th is 81. All right, I put these properties up here, and we're going to use those properties to solve these problems, plus that we've done. In the A, I'm multiplying, so I'm going to use property 1, where when I'm multiplying and I have the same base, I can add those exponents. So this is going to be x to the 1/3 plus 5, 6. I'll need to get a common denominator and add, which is a pain, but this 1/3 would be 2, 6. So I would end up with 7, 6. And this would be my answer now. If they ask for your answer in exponent form, this is what you would give. If they ask for it in radical form, it would look like this. Now, typically, they're going to want the answer in the same form that it was given, meaning that if they give you the problem in radical form, that's how they want the answer. If they give it to you in exponent form, that's how they want the answer. For this next one, when I have a power raised to a power, I multiply exponents. So this is going to be y to the whatever 2/3 times 3/4 is. And when I multiply that, it's y to the 1/2. All done. When I'm dividing, I subtract exponents. So it's going to be z to the, and I need to do 1/3 minus 1/4. Means I need a common denominator. So I'll write my z down here. That would be 4 over 12, multiplying top and bottom by 4, multiplying top and bottom by 3. This would be minus 3 over 12. So this is z to the 1/12. If you were to write it in exponent form, which is probably not how they want it since the problem was given like that, but I'm just going to write it anyway, it'd be 12th root of z. All right, when I have a power raised to power, I multiply. So this would be a to the 1/3, negative 1/3 times 6 is negative 2 over b to the 1/2 times 6 would be 3. Now they don't want your answers with any negative exponents. So what you're going to need to do is you're going to need to take this thing, because a negative exponent means 1 over, and you're going to have to put it down there in the bottom with your b. Because the b is down there, and a says, ooh, I belong down there too. That's what that negative exponent means. And that would be your answer here. Let's play this game. This would be x to the minus 12. Y to the half of 4 is what, 2 over x to the 10th. Y to the, 3 halves, yuck. All right, so now I have some x's and y's on top. I can do something with those. With the x's, notice that these 12 x's really belong in the bottom with those 10. You really have x to the 22nd on the bottom, because once that 12 comes down here, it's 12 plus 10, so that's x to the 22. This y is y to the, and I need to do 2 minus 3 halves, so let's do 4 over 2, which is 2, minus 3 halves. So that's y to the 1 half up here, and that's your answer. Now I know that sometimes these get all wiggly and confusing, and you may need some extra help with these. Please let me know if you do, and I will be sure and answer your emails. And we can probably do a collaborate on this, because it might be good to go over all of these properties a little bit slower and review that 055 material. All right, have a good day, and this chapter is probably one of the most frustrating, so be prepared, you're not alone.